Hello and welcome. Even though I am not physically here today, I am still here with you to teach you about more trig graphs, just what you guys love, trig graphs. So today we are going to focus on the tangent, the cotangent, secant, and cosecant graphs. If you were in Algebra 2H, then you definitely touched on these at the end of the year in Chapter 11. And maybe you looked at them in FST as well. If not, then here's a review for you. So today we're going to identify the period and the graph of trig functions of the tangent, cotangent, secant, and cosecant. And the first thing we're going to look at are the periodic properties. So tangent and cotangent are going to have a period of pi. What that means is every pi units, your graph is going to start repeating itself, and that's for tangent and cotangent. Remember, that's different from sine and cosine, because what did sine and cosine have a period of? Yep, 2 pi. So with tangent and cotangent, the period is going to be pi. Now, for the reciprocals of sine and cosine, which the reciprocal of sine is cosecant, and the reciprocal of cosine is secant, those are going to have a period of 2 pi. Sorry, I know it's a little shaky. So these are both going to be 2 pi, which means those are going to repeat every 2 pi units. Okay, so tangent and cotangent repeat every pi. Cosecant and secant are going to repeat every 2 pi. The next thing I want to talk about are asymptotes that occur because they occur on all 4 of these types of graphs. And I want you to think about why that is. So when you have asymptotes, do we remember what types of values those occur at? So asymptotes are going to start to happen when you have values that are undefined. So I want you to think about, okay, where would my tangent be undefined? So to do that, let's think about our unit circle. So if we think about our unit circle, okay, I drew a nice little one right here for us. We know tangent is going to be sine over cosine. Undefined happens when we have 0 in the denominator. And because this is cosine, you want to say, okay, where is the cosine going to be 0? Well, one spot is right here at pi over 2. So at pi over 2, you have 0 as your x value and 1 is your y value. So when you do the sine of pi over 2 over the cosine of pi over 2, you have 1 over 0, which results in something that's undefined. So pi over 2 is one place where an asymptote is going to occur. Now, because it's periodic, it keeps repeating. So let's think of another place where you would have 0 on the denominator. It's going to be right here at 3 pi over 2, because again, your x value would be 0. So really, to get from pi over 2 to 3 pi over 2, do you know what you added there? I'll let you think about it for a second. So it's half of the circle. Half the circle is what? Half the circle is pi. So you could add pi to get the next time it goes to undefined. Then if you added pi again, you would get another value. And then you could keep adding pi to find out where they were undefined. Now with cotangent, it's going to be very similar. But with cotangent, sine is on the bottom. So we want to find places where sine is going to be 0. So the first place, it's going to be easy, is pi. Easy as pie, get it? So here it's 0. So if you did 0 plus your value, that does work too. Pi is a lot easier to think about. So if you have pi here, then you have negative 1 over 0. That's going to be undefined. And then if you kept adding pi, you get to 2 pi, 3 pi, 4 pi. All of those are going to be places where it's undefined. So what we can do is we can set up a general equation where you have the tangent asymptotes and the cotangent asymptotes. So for tangent, it's going to start at pi over 2, and it's going to go every pi units from there. So pi over 2 plus k pi, where k can be any integer. So that means even a negative integer. So you could rotate around the other way. Where cotangent is going to be pi plus k pi. So like I was saying earlier, it could still be 0 if you just plugged in a negative 1, right? Pi minus pi would be 0. So 0 is the spot where it is going to be undefined. So we're going to use those when we are talking about our graphs. So for your tangent, the center of the tangent is going to be right here at 0, 0, and then it follows a cubic type pattern. So it's going to curve. It's going to curve towards your asymptote, which repeats every pi. So from here to here, this does represent pi units, because from negative pi over 2 to 0 is pi over 2. From 0 to pi over 2 here is pi over 2. Pi over 2 plus pi over 2 is pi. Thus, this would be 1 period. Okay, so you'll have one cubic looking function for every period. Okay, and this is graphed from negative pi over 2 to pi over 2. And this would just be the function y equals the tangent of x. Okay, and then, of course, if you have a negative here, it would flip this around and you would be going down from left to right. Okay, and then let's look at a few periods put together. So what's going to happen is every pi units, you're going to come up with an asymptote. So if you add pi to pi over 2, you get 3 pi over 2. That's where your next asymptote is going to be. You can also subtract pi from here. That's where your next asymptote is going to be. And you can see that these lines are going to start curving up towards them, but they will never cross them. Remember, it's never going to cross a vertical asymptote. Okay, and then for your cotangent is a reciprocal. This is graphed from 0 to pi, and that's because your first asymptote occurs at pi. The cotangent, just like the negative tangent, is going to be going down from left to right. Notice here that the center point is at pi over 2. Okay, where was the center point on tangent? 0. All right, and this is still 1 period. It's just graphed from 0 to pi. Okay, and then if we want to see what more of these look like, you can see you still have the pi over 2. Your first asymptote is going to occur at pi. Then it's going to keep continuing at pi units. So if you do pi plus your k value, you're going to have an asymptote right here, which you can't see it because it's on the axis, so that's why I just labeled it here, but you are going to have one every pi units. And this might be good to label in so we don't forget about that one, because it is going to happen every pi. Okay, all right, stay tuned for page 2.